Okay, so this is a primary concept of rate equation. So select the answer with the correct relationship for the rate of the reaction given below. So when you have this type of equation, as I have told you before, there are many ways that you can write the rate law. You can use the rate law by using the decreasing concentration of the reactants. You can write a rate with respect to the increasing concentration of the products. You can write down the differential form of the rate, which is given here. And you can use the orders, which you can write this as in the rate law. But here they have not asked about the rate law, just the rate. So one thing that you need to understand here is all the rate that is related to MnO4 minus, C2O42 minus, and H plus, it should be negative because they are consuming, they are the reactants. So basically, if I want to write the rate of delta MnO4 minus, here in this case, concentration difference, it should be negative. There should be a negative sign here, and divided by the delta T time. And then I have again my reactant as C2O4. So C2O4 also 2 minus. This also should have a negative sign because this is also consuming. So when you write this reactants, you have to use negative mark. When you write with respect to the products, you can use the positive mark. So this is also delta T. Okay. So this is the rate. This is this. But when you want to compare this rate between these two, as I told you before in many cases, you have to consider the reciprocal of the stoichiometry, right? Because you can imagine when 2 moles of MnO4 minus is consumed, 5 moles of C2O42 minus is consumed. So you cannot just equalize these two. If you equalize these two, it is wrong because you have to give the same contribution by considering the stoichiometry. Otherwise, what will happen here is you will have a rate with respect to this one, a one rate, with respect to this one, another rate. There is no problem. But the problem is the entire reaction, there should be only one rate. Okay. So to make this balance, MnO4 minus 2 times consumed when C2O4 minus is 5 times consumed. So no problem in that. But when you compare these two, you have to give the numerical coefficient same to this and this when you want to equalize the rate. Okay. At this point, what you have to do here is use the stoichiometry. So basically, MnO4 minus the stoichiometry is 2. So when you have 1 mole of this that is consumed, for an example, okay, how you are going to make it 1 mole? Because the stoichiometry is 2, so I am going to get 1 over 2, the reciprocal. And here the reciprocal is 1 over 5. So this is the straightforward relationship. Okay. These negative marks going to cancel. So this is the only relationship that you are going to get here. What is the answer based on this? So basically there should not be any negative marks. So this cannot be. And what are these 10? I don't know. What is this 10? And when you have MnO4 minus over T, this should be here. The factor that they have this change. So you can get this 2 here, so it will be 2 over 5, and there is no 2 here in the bottom. Okay, so basically this is the correct option, fourth one. And you can write all these things. So here when you write in with respect to manganese 2 plus, you need to put plus. Okay, so this is another very basic theoretical concept.